Newton's second law, project and demonstration. My table of contents includes the abstract, introduction, physical principle, my project in detail, experiment build, data, my graphs, materials list, and my revisions. Abstract. I'm drawn to this project due to my fascination with Newton's second law as discussed in Chapter 2 of our class. The lab we conducted on this topic particularly interested me. Here I've created a system to manipulate mass and acceleration, showcasing the link between force, mass, and acceleration. Using a Hot Wheels ramp adjustable between 2 points, I can vary the ramp angle to affect the acceleration of the toy cart. Additionally, I can adjust the cart's mass by adding small weights. Our goal is to graph these findings to visually represent the relationship between force, mass, and acceleration. Introduction: Exploring Newton's second law. According to Newton's second law, the formula is F equals ma. Force equals mass times acceleration. For the key concepts, we have describes the relationship between force, mass, and acceleration, fundamental to understanding motion in physics, explains how an object's motion changes with applied force, basis for many practical applications in engineering and science, and helps predict the behavior of moving objects. For the project overview, we have conduct a practical experiment to demonstrate Newton's second law, measure how varying the acceleration affects an object's force, analyze the impact of changing mass on force, highlight the principles and importance of this law in understanding motion, and today we're going to provide a real-world example of Newton's second law in action. Physical principles, Newton's second law. Acceleration A, mass m, and force F are related by Newton's second law, F equals ma. It asserts that an object's mass and the acceleration it produces are directly correlated with the force applying on it. This key principle of physics clarifies how objects move in response to outside forces. We'll use a practical experiment in our project to demonstrate this idea and highlight how crucial it is to understanding motion. Project in detail. Focus: investigate F equals ma. Illustrate force, mass, and acceleration relationship. Setup: equipment, ramp, toy car, weights, tape measure, and scale. Procedure: to use weights to control cart's mass and measure force by the distance the cart travels. Alter acceleration by changing the angle of the ramp and measure force exerted at the end of the ramp. Method: conduct experiment trials sliding car down ramp with varying mass. Conduct experiment trials altering the angle of the ramp, thus changing the acceleration. Graph the relationship of mass/acceleration versus force. Key points: graph shows linear relationship confirming F equals ma. Vary cart mass and ramp incline to observe effects on force. And now into my video. Hi, my name's Aiden, and today we're going to be filming an experiment proving Newton's second law. So let's get into it. For our experiment, I have a ramp, I have a Hot Wheel, and I have weights that I'm going to be adding to the Hot Wheel. And we're going to see how changing mass and changing acceleration changes force. For our first experiment, we're going to see how far this Hot Wheels car travels with no weights on it at all. So for our first trial, we'll be doing the car down the Hot Wheels ramp with no weights, and we're going to see how far it goes. As you can see, the Hot Wheels car traveled 77 inches beyond the end of the ramp. And for our next trial, we're going to be putting a half an ounce weight on the car to see how that affects how far it extends past the ramp. And this is going to be our first trial with added weight. I guess technically our second trial. This is the Hot Wheels car with half an ounce of weight added. And for our second trial, the Hot Wheels car traveled about 94 inches past the end of the ramp. For our third trial, we're going to be adding half an ounce more weight to the Hot Wheels car. So in total, this now has about an ounce of added mass. Let's see how it does on the Hot Wheels ramp. Looks like it went pretty far. Looks like this time the Hot Wheels car traveled about 100 inches past the end of the ramp. Hi guys, this is the other half of my project. This is another piece of Hot Wheel track reinforced with a little slide of wood to make it more stable. And I pretty much just cut this Hot Wheel car in half to aid in the experiment. And I've got a jack stand where I'm gonna adjust the angle of the car to really just vary its acceleration. And if I can peel this off, I have a scale at the end to measure the amount of force the cart puts at it at the end of the ramp. And with this, we're really just going to see how the acceleration of the cart changes the force. Our setup is going to look like this. So we're going to set the ramp at different angles, and depending on angle, we're going to see how much force is exerted at the end of the ramp via the scale over there. Just like this. And as an example, we set the ramp at a lower angle, and we're going to see how that changes the force exerted at the end of the ramp. Without further ado, here's our results. Used Hot Wheels track, weights, a Hot Wheels car, tape, a tape measure, and the scale. I also used a jack stand and a couple other items for this project as well. Peer review and revisions. I made a ton of revisions after reading my peer reviews. These two graphs I made most of the result of today's experiment. From this, we can see that both acceleration and mass have a linear relationship with force, with the influence, proving Newton's second law. I kept all the images I used in the graph, as well as editing. Thanks so much for watching. I also added a table of contents slide at the start to give a better layout to my presentation. Additionally, I removed my drawing and added a video demonstrating my project. I then graphed my data and presented it on the next slide. I had to tweak how my project measures force because the scale didn't read correctly when it hit with a large amount of mass. Instead, for the first half of my project, I measured how far the car rolled past the end of the ramp and how increasing the mass affected it. For acceleration, I still used my original plan with the ramp because the scale did not error out with lighter weight. Thanks so much for watching my presentation video, and I hope you have a nice day.